goal of 5G is to provide gigabit per second data rates anywhere at any time. It will change our lives by making the Internet of Everything mobile. This is driving new research which presents many new design and test challenges. Microwave and millimeter wave frequencies are being researched to extend today's cellular bands for higher data throughput applications using wider modulation bandwidths. New emerging waveforms such as FBMC, GFDM, UFMC, and filtered OFDM, and many others are being researched. With 5G in its early stages of research, a high degree of flexibility is required for a testbed solution, including the need to generate and analyze new emerging candidate 5G waveforms, the need to support a wide range of proposed modulation bandwidths from megahertz to gigahertz, and the need to support a wide range of frequency bands from RF to microwave to millimeter wave. To address these challenges, Keysight Technologies' flexible testbed for 5G waveform generation and analysis consists of an arbitrary waveform generator with the System View 5G baseband exploration library and Signal Studio for custom modulation software installed on the embedded controller, a PSG vector signal generator to generate wideband signals up to 44 GHz, a UXA signal analyzer and/or a 63 GHz oscilloscope with 89600 VSA software for high-frequency wide-bandwidth signal analysis. For millimeter wave frequencies, a millimeter wave up converter and down converter can be used, along with MXG microwave analog signal generators for the LOs. Keysight Technologies software is the core of this 5G testbed to provide flexibility in generating and analyzing new candidate waveforms. 5G waveforms are generated with System View 5G design simulation software or Signal Studio software for custom modulation. Custom signal analysis is performed with Keysight's 89600 VSA software, which provides a consistent user interface and measurement algorithms across Keysight signal analysis test equipment and simulation platforms. To show the flexibility of this testbed, a System View waveform is created with a notched FBMC signal and an LTE signal to evaluate the coexistence of a candidate 5G waveform with a 4G waveform. The 89600 VSA software demodulation of the LTE signal measures an EVM of 0.6%, showing good coexistence for this scenario. To show the flexibility of performing what-if scenarios with this testbed, the FBMC notch width is varied to evaluate the impact to LTE EVM. We can see that the LTE EVM increases as the FBMC notch width decreases. Now let's have a look at a wideband waveform. Signal Studio for custom modulation is used to generate the wideband FBMC waveform file. The flexibility to support a wide range of proposed modulation bandwidths from megahertz to gigahertz at RF and microwave frequencies is shown with this 1 GHz wide FBMC signal centered at 28 GHz, or with this 1 GHz wide OFDM signal centered at 28 GHz. Millimeter wave up converters and down converters further extend the testbed's flexibility to support wideband modulation bandwidths at millimeter wave frequencies. Seamless integration between design, simulation, and Keysight test equipment enables wideband amplitude and phase corrections to be performed using the 89600 VSA software adaptive equalizer. This improves waveform quality for very wide gigahertz bandwidths. This shows the resulting demodulation of the 2 GHz wideband millimeter wave 16 QAM waveform without adaptive equalization, after corrections have been applied to the wideband waveform. Keysight Technologies' new testbed for 5G waveform generation analysis provides flexibility to generate and analyze new emerging candidate 5G waveforms, support a wide range of proposed modulation bandwidths from megahertz to gigahertz, support a wide range of frequency bands from RF to microwave to millimeter wave. To learn more about Keysight Technologies' flexible 5G waveform generation and analysis testbed, please download this new white paper at keysight.com/find/5G-insight. Keysight. Hardware plus software plus people equals 5G insights.